For question 1, we need to use the 0.99 degree of confidence to find out what is the confidence interval for the population mean. So from the data given in the problem, we know that the sample size n equals to 42, and the sample mean x bar is equal to 5.5, and the sample standard deviation s is equal to 1.1. And we need to find the t-value. We need to refer to the t-table, and we know that t for 99% of confidence level, we need to refer to the 41 degree of freedom. Since the sample size is equal to 42, we need to minus 1 by the sample size, and we will get the t-value is equal to 2.701. And we have those data, we just plug it into the formula, which is x bar plus minus t multiplied by s over square root of n. And we will get 5.5 plus minus 2.701 multiplied by 1.1 over square root of 42. And we will get 5.5 plus minus 0.458. Since I want my answer to be more accurate, I will put it into 3 decimal places. And in conclusion, we will get the confidence limit are 5.042 years and 5.958 years.
For question number 2, what is the difference between a null hypothesis and an alternative hypothesis? The difference between a null hypothesis and an alternative hypothesis is null hypothesis means that there are no changes in the hypothesis, and alternative hypothesis means that a statement that is accepted if the sample data provided sufficient evidence that the null hypothesis is false. For B, what is the difference between a one-tailed test and a two-tailed test? The difference between one-tailed test and two-tailed test is one-tailed test is used when we want to test if the value is greater than or less than a certain value, while two-tailed test is used when we want to test if the value is different from a certain value, either larger or smaller. For C, what is meant by a p-value? P-value is the probability of observing a simple value as extreme as or more extreme than the value observed, given that the null hypothesis is true. For question D, we know that the mean is 6.6 pounds, and this is one sample of 7 sample, and a sample of 7 infant is randomly selected. So step 1, we will state the null hypothesis and the alternative hypothesis, which is the null hypothesis is HO, which equal to mu equal to 6.6, and H1 is mu not equal to 6.6. And step 2, we will set the significant level, which is 0.05, and we will using t-test for this question. In step number 4, we will form a decision rule, which is to reject HO if computed P is larger than plus minus 2.447. In step 5, we will calculate p-value, and firstly we'll calculate mean and sample standard deviation. So after calculate mean and sample standard deviation, we put in the p-value formula, which is x bar minus mu divided sample standard deviation divided by n, and we will get p-value is 2.151. So in conclusion, 2.151 does not fall in the rejection area. We are failed to reject HO. We can conclude that the mean weights of newborns has no difference at 0.05 significant level.
For question 3a, the 5 step to perform hypothesis testing is: first, state null and alternate hypothesis. Second, select a level of significance. Third, identify the test statistic. Fourth, formulate a decision rule. And the last step is take a sample and arrive at decision whether to reject HO or do not reject HO. So for question 3b, the first step we need to do is state the HO and H1. Since the question asks us, can we conclude that the mean salary of the fast food workers are greater than the restaurant workers? So our H1 is mu fast food greater than mu of restaurant. And on the other hand, the HO must be mu of the fast food workers less or equal than the mu of the restaurant workers. After solve the step 1, we let us move to the step 2, which is we need to state the level of the significance, which is alpha equals to 0.10. After that, step 3 is we need to identify the test statistic. So in this case, we need to use the t-test. After that, from the step 1, we know that this is a one-tailed test. so that we can formulate the decision rule in step 4, which is reject HO if computed T larger than 1.363. So how we get the T value is equal to 1.363. Since this is a two sample hypothesis test, we need to add up the sample size of the two sample and minus by 2 to get the degree of freedom. So in this case, the sample size of the fast food worker is 6 and the sample size of the restaurant worker is 7. So we just add up the 6 and 7 and minus by 2 and we will get the degree of freedom is equals to 11. So we just look at the degree of freedom of 11 and the 0.10 significant level for one tail test, we will get the t-value is equal to 1.363. So now let us move to the last step. I'm using the calculator to help me calculate the sample mean and the sample standard deviation, which is the x bar of fast food is equal to 142.5, x bar of restaurant is equal to 130.2857, S of the fast food is equal to 12.2434, S of the restaurant is equal to 15.7873. We need to use this value to help us calculate the S squared P, which is the pool sample standard deviation. The S squared P is calculated by N fast food minus 1 multiplied by S fast food square plus N restaurant minus 1 times S restaurant square divided by N fast food plus N restaurant minus 2. So just plug in the value just now we calculate and we will get 6 minus 1 times 12.2434 square plus 7 minus 1 times 15.7873 square divided by 6 plus 7 minus 2. And also we will get 5 times 149.9890008 plus 6 times 249.2388 divided by 11. And we will get 749.504 plus 1495.4328 divided by 11. And lastly, we will get 2244.9368 divided by 11. So lastly, we will get x squared p equals to 204.0852. After that, we need to use the s squared p to help us calculate the t-value. The t-value is calculated by x bar of fast food minus x bar of restaurant divided by square root of s squared p times 1 over n fast food plus 1 over n restaurant. So we will get 142.5 minus 130.2857 divided by square root of 204.0852 multiplied by 1 over 6 plus 1 over 7. We will get 12.2143 divided by square root of 204.0852 multiplied by 13 over 42. And at the end, we will get the t-value is equal to 1.5367. So since I want to get the value in the 3 decimal places, so we will get the t-value is equal to 1.537. So in conclusion, since the 1.537 is fall inside the rejection area, so we need to reject HO so that we can conclude that the mean salary are greater for the fast food workers than the restaurant workers. At last, we know that the p-value is between 5% to 10%. It is because the t-value of 1.537 is between 1.363 to 1.796, and we just look upward to the significant level for one-tailed test, we will realize that the p-value is between the 0.10 to 0.05. And we just convert it into percentage and we will get the p-value is between 5% to 10%. For question 4a, the first step we need to do is state the HO and H1. Since the question asks us what is the decision regarding the hypothesis that the training was effective in improving the customer relationships, so our H1 is mu of difference larger than 0. On the other hand, HO is mu of difference less or equal than 0. Step 2, we need to select the significant level, which is alpha equals to 0.05. Step 3, in this case, we need to use t-test. Step 4, since this is a one-tailed test, our decision rule is reject HO if calculated t larger than 1.943. We can get this 1.943 by referring to the t-table on the degree of freedom of 6, which is sample size 7 minus 1. After that, we have several steps in step 5 due to calculate the t-value. At first, we need to create a table that contains first column is D, which is differences. The second column is d minus d bar, which is the d bar is the mean of the differences, and the third column is d minus d bar squared. After I calculate the details, we will get the sum of the differences and the sum of the d minus d bar squared. What is the d bar? D bar is the mean of the differences that calculate by the sum of d divided by n, which is 14 divided by 7, and we will get d bar equals to 2. After get the d bar equals to 2, we just plug in into the formula in the table, which is d minus d bar square, and we will get the sum of the d of d bar square is equal to 26. So we can use this value to calculate the SD. SD is the standard deviation of the differences, which is calculated by square root of sum of d minus d bar square divided by n minus 1, which is square root of 26 divided by 6, and we will get the SD is equal to 2.082. Lastly, we just plug in the standard deviation of the differences and the mean of the differences into the t-value formula, which is t equals to d bar divided by sd over square root of n. And we will get 2 divided by 2.082 over square root of 7, and we will get 2.542 is the t-value. In conclusion, since 2.542 is fall inside the rejection area, so we need to reject HO. At last, we can conclude that the training was effective in improving customer relationships.
For question 4b, we are given an incomplete ANOVA table, and we have to complete the table answering the questions using the zero point zero 0.05 significance level. In question 1, we know that the treatment degree of freedom is calculated by k minus 1, and we are given the degree of freedom for treatment is 2, and we can know that the treatment degree of freedom is equal to 3 minus 1, which is 2, and there are the total 3 treatments. For question B, the total degree of freedom is equal to n minus 1, and we have 12, and we have total given that 11 in the degree of freedom. So we know that there is 12 minus 1 equal to 11, and there are total 12 sample size in the question. For question C, we need to find the value of critical F, and after we find the treatment degree of freedom and the error degree of freedom, we can find it in the table, which is the table for F value in 0.05 significant level, and we can know that the critical value of F is equal to 4.26. For question B, we have to state the null hypothesis and the alternative hypothesis, which is H0 is mu1 equal to mu2 equal to mu3. And H1 is the means are not all equals. For question E, we have to form a decision rule, which is reject H0 if computed F is larger than critical F. And we know that computed F is equal to 8 and the critical F is equal to 4.26. Thus, 8 does fall inside the rejection region. Reject, we will reject H0, and we can conclude that the means are not all equal. In question 4c, we are required to use 0.05 significance level in 5 steps hypothesis the testing process to check if there's a difference in the mean flight times among the 3 airlines. For question 4c, step 1 is to inform null hypothesis and the alternative hypothesis, which is H0 is mu goes equal to mu jet rate equal to mu cloud trend, and H1 is the means are not all equals. In step 2, we have to use a zero point zero 0.05 significant level, which is stated in the problem. In step 3, we are using F statistic to solve the problem. In step 4, we have to form a decision rules, which is reject H0 is the computed F is larger than 3.302. In step 5, we will do another table to calculate our computed F, and we will get the computed F is equal to 3.04. Thus, 3.04 does not fall inside the rejected region, so do not reject H0. We cannot conclude that there is a difference in the mean flight times among the 3 airlines.